Hello everyone, welcome back to PSC interview questions. The one general question that has been asked previously related to thermal power plants, like the question is, there are two steam power plants, one is at Shimla and another one is at Mumbai. So which one have the higher efficiency and which one will have the network output is higher? So this common question previously lot of times asked in the BRC interview as well as the other PSU exam interview. So let's dive into in and let's find out for which thermal power plant the net work done is higher. So let's check it.
So answer for this question is nothing but a steam power plant is more efficient in a cold place like Shimla than in a hot place like Mumbai. So thermodynamic reason behind is, let's see. So we know how to calculate the efficiency of a steam power plant. Mainly depends on temperature difference between the your hot heat source at a boiler and heat that is the sink temperature, nothing but condenser. So source temperature is about boiler temperature and sink temperature is nothing but your condenser temperature. So efficiency is equal to 1 minus T sink divided by T source. So T source inlet condition of the boilers are same at Shimla as well as at the Mumbai. So there is only difference in the T sink temperature. That T sink temperature is nothing but your condenser temperature. So let us see what is the condenser temperature at Shimla and at Bombay. So Shimla is a cold climatic condition, so lower ambient temperature, lower condenser temperature and pressure as well. So we can see that due to the lower condenser temperature at Shimla than Bombay or Mumbai, so your efficiency will be higher in the Shimla. Let us assume another way. Let us think about another way. Due to lower condenser temperature and pressure, we can see higher enthalpy drop across the turbine. Definitely, if higher enthalpy drop across turbine, which will convert more turbine work, so you will again get higher efficiency. So if you look out for Mumbai, hot and humid climate is there, so higher ambient temperature, higher condenser temperature and pressure. So that is the reason, so that we will get a lower efficiency at the Mumbai. So T sink temperature is high than Shimla. So if your T sink temperature is higher, definitely you will get lower efficiency. So another thinking way is only condenser temperature and pressure will be higher at a Mumbai. This will cause a lower enthalpy drop. If lower enthalpy drop means your lower turbine work and lower efficiency. So practically you have to understood this thing. In Shimla, steam expands more in turbine due to lower back pressure. Second thing is, cooling is more effective in condenser. Cooling is more effective due to condenser vacuum improves. Third thing, this is nothing but network output of the thermal. Network output you will get high at in case of Shimla, and hence efficiency increases. So final conclusion is like for the same boiler inlet conditions, it is more important. For same boiler inlet conditions, a steam power plant in a Shimla will be more efficient. Okay, and now if I told you what will be the condenser conditions, like Shimla condenser temperature, if you assume 30 degrees Celsius, then in Mumbai condenser temperature will be 40 degrees Celsius. These are the assumptions for better understanding. So condenser pressure like Shimla 0.04 bar, and similarly for Mumbai you can take 0.075 bar, just little higher. So we know Shimla condenser temperature and pressure will be lower than Mumbai. So if you go for turbine exit enthalpy, numerically we will understood how the efficiency and work expansion is higher in Shimla. So turbine exit enthalpy from TS diagram we can plot. So lower condenser pressure means more expansion and lower exit enthalpy. And this is nothing but at Shimla you will get turbine exit enthalpy, that is nothing but H4. So that enthalpy will be lesser than Mumbai. So if you assume here turbine exit enthalpy as a 2900 kilojoule per kg, and for Mumbai it is 2300 kilojoule per kg. This is for numerical purpose. Just assume the data, this basic data we will assume it, and we will calculate the what will be the net work done and what will be the efficiency. So if you calculate the turbine work output, that is nothing but your enthalpy at a 3, enthalpy at a turbine inlet minus enthalpy at a turbine exit. So for Shimla and Mumbai, the enthalpy at a inlet we will assume 3500, because inlet conditions at both the power plant will be the same. So if you assume 3500 minus 2100, it will gives enthalpy at Shimla 1400 kilojoule per kg, as shown in the figure also. So Mumbai is for same calculation for Mumbai, 3500 minus 2300, it will gives 1200 kilojoule per kg. So definitely Shimla turbine produces more work. You can see 1400 is higher than 1200. So if you assume pump work is a 5 kilojoule per kg, nearly same for all the power plants. So pump work is a 5 kilojoule per kg. So net turbine work is nothing but your turbine work. So net work is nothing but your turbine work minus your pump work. So Shimla you will get 1395 kilojoule per kg, and Mumbai 1195 kilojoule per kg. So this numerical will better understanding as network is higher in a Shimla. So if you look out for heat supplied for calculation of efficiency, heat supplied in both the cases will be the same, because heat inputs are same. If you assume heat supplied is enthalpy at boiler or enthalpy at a turbine inlet minus enthalpy of enthalpy H2, S3 minus H2 will be heat inlet. So 3500 minus 2000. 3500 minus 200. If here we are assuming enthalpy H2 will be a 200 kilojoule per kg. So heat in inlet will be a similar for both the cases, 3300 kilojoule per kg. So thermal efficiency we can calculate from it. Shimla for work done upon heat supplied. For work done we are getting the values like 1395 divided by 3300. So nearly you will get efficiency 42.3%, and for Mumbai 1195 divided by 3300. So nearly you will get 36.2. This data is very better to understand that definitely the efficiency at the Shimla is higher than Mumbai. So this concept we are actually understand already by 1 minus T sink divided by T source. So T source temperature will be a same for both the cases, only T sink temperature is going to change, that is your condenser temperature. So condenser temperature will be a lower at a Shimla. Definitely you will get better efficiency at a Shimla than Mumbai. So this way understand by both way, by numerically as well as by conceptually. So and definitely final comparison, if I look out for parameter, condenser temperature is lower at a Shimla, higher at a Mumbai, turbine expansion is greater at a Shimla, lesser at a Mumbai, enthalpy drop will be higher at a Shimla, lower at a Mumbai, and definitely your net work is higher at Shimla, and efficiency is also higher at Shimla. So this is the final comparison. And if I want to conclude in one line or interview like BRC or something PSU, so I can conclude like a steam power plant located in a cold region like a Shimla produces higher net work and higher efficiency than Mumbai. This is because due to the lower condenser temperature, which increases turbine enthalpy drop and improves cycle efficiency. So if you like these interview questions like BRC or PSUs, please do watch this channel, and please I will recommend do not forget to subscribe this channel. So thank you very much.